Good afternoon, students. We continue with the second part of a priori algorithm. We had begun the a priori algorithm in the previous lecture. So we had seen that this is a sample data set and which consists of certain transactions that consist of items I1, I2, I3, I4 and I5. Now, as we had learned, there are two steps in a priori algorithm. So in the first step, what we do is we first find out the support count of each of the items. When I want to find out the support count of each of the items. That means I'll be counting how many times I1 appears in all the transactions, how many times I2 appears, and similarly I'll do this for the uh, all the items. So if I count I1, 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 so I1 appears in P100, then P400, P500, 700, P800, and P900. So I'll count how many times this is, and similarly I'll count for all other items. So when I count for all these items, this comes out to be 67622. Item I5 appears 2 times. As we can see, item I5 is in transaction P100 and in transaction P800. So this is the first C1 set that consists of all the items and the support count. So now what I do in the pruning step, I'll just remove all those items whose support count is less than the minimum support threshold. Now this support threshold is already given to us in the question, and in this problem we are given that the minimum support count required is 2. So what I'll do, because here we see all the item support count is not less than 2. So all these items in C1, they will move to the L1 set. Now in the second step, what I'll do is I will make this is one item set. Now in order to form a second two item set, what I'll do, I'll combine each of these items with the other items. So in this way, I'll form sets of I1, I2, I1, I3, I1, I4, I1, I5, then I2, I3, I3, I2, I4, I2, I5, then I3, I4, I3, I5, and then I4, I5. So I've listed all these sets over here, and then once again I'll scan the data set or the transaction, and then I'll count how many times I1, I2 appears, how many times I1, I3 appears. So as you can see here, the count of these items, say for example I3, I5 is 1. So I once again scan the database and I see that I3, I5 is only in transaction 800, and that is why the value here is written as 1. If I want to check for I2, I3, I just see 4 transactions are there. I2, I3 is in transaction 300, then 600, then 800 and 900. So I have listed the support count of all these two item sets. Now here in this, we can see some of the item set have the support count of 1 and some 0. So our pruning step, according to pruning step, we have to remove those items. So I remove these items I1, I4, I3, I4, I3, I5 and I4, I5 from C2, and the L2 set contains all the remaining items. So after pruning, these are the remaining items which are listed in L2. Now once again I will form sets from I1, I2 with the next all the items. Then I1, I3 with the remaining items, I1, I3, I5 with the remaining items, I2, I3 with the remaining, and in this way some of the items will be duplicate and only remaining some of the items will be remaining. So I will add all those items, so I can form only these 3 item sets, these only 2 sets of 3 item sets. So once again what I will do next is I1, I2, I3, I'll just try to find out how many times I1, I2, I3 appears in my transaction. So when I count I1, I2, I3, I1, I2, I3 is in transaction 800 and 900. So that is why the support count here is 2. Similarly, I will count for I1, I2, I5 and the support count is 2. Once again, all these items, they have the values of support count greater than or equal to the minimum support count. So in the pruning step, I will not be pruning anything, and all these items go in the item set, this L3 set. So here we can see that we can find I1, I2, I3, the support count of this 3 item set is 2. So in this way, we can find the frequent item sets using a priori algorithm. Once we find frequent item sets using a priori algorithm, our next step is to generate strong association rules. And in order to find out the strong association rules, what we need is we require the term confidence. So how do we use confidence to generate association rules? For this, we have a 2-step process. In the first step, for each frequent item set L, we generate all non-empty subsets of L. And from all non-empty subset S of L, we output the rule in the form of S arrow L minus S. So S means the non-empty subset S and L is the entire set. So that this rule is a strong rule if the support count is greater than the minimum confidence. So we just check for confidence threshold in forming the association rules. So here is an example of generating association rules with the help of the frequent item set using a priori algorithm. So we have generated two frequent item sets, but here the example is only for the first I1, I2 and I5 item set. So what we will do, we will just form non-empty subsets. So these are the various subsets of I1, I2 and I5. So we take the first subset I1, I2 and what is L minus S? This I5 is the remaining. So S arrow L minus S. So if I take I1, I2, then the L minus S is I5. So this forms one rule. Then the other subset is I1, I5. So the remaining L minus S is I2. In the similar fashion, I write all these rules. Now, in order to write the confidence value, what I'll do is I will find the support count of, because the formula says the support count of L divided by support count of S. So the support count of L means frequent item set L. So as we have seen, the frequent item set was I1, I2, I5. So here you can see the L is the entire set. So this set consists of I1, I2, I5, and as we had seen, the support count of this was 2. So in all these terms, confidence terms, you have the first figure, the numerator as 2. Now comes support count of S. So support count S means the subset part, and this subset part is on the left hand side. So what I'll do is I'll find the support count of I1, I2, I1, I5, I2, I5, I1, I2, and I5 from the tables which we had generated previously. So as you can see, the support count of I1, I2 is 4. So we can check this support count of I1, I2. I1, I2 was 4. So from here we put up these values of support count. I1, I5 is also 2. So you can see here the support count of I1, I5 is 2. The support count of I2, I5 is 2. And support count of I1, I2 and I5, we can check that this is 6, 7 and 2. Let's check I1, I2 and I5. Support count of I1, I2 and I5 is 6, 7 and 2. So we have substituted those values over here and find out the confidence. Now if the minimum confidence threshold is say 70%, then only these three rules whose confidence is 100%, they satisfy this minimum threshold condition. So these three are called as a strong association rules. That's all in this video. Thank you.